Hello all, welcome back to my YouTube channel all about VLSI. In our previous videos, we have discussed about what are the signals which are associated with each and every channel. Like for example, in our write address channel, we have some set of signals, and read data channels, we have some set of signals, and the read response channel, we have some set of signals associated with the channel. And we have learned what are the significance of those particular signals in more detail. We have discussed this particular signals, and we also discussed about what do you mean by out of order transaction and in order transaction, and what are the different type of channels which we are going to have. This and all things we have discussed in our previous sessions, and I hope you have clearly understood these concepts well. Now in this particular session, we are going to start with the discussion of basic burst operation. Like if we want to perform a read operation, then what are we going to do, and if we want to perform a write operation, then what are we going to do. Let us try to understand with the help of this particular examples. Now let's say if I am going to perform a read burst operation. Let's say if I want to perform a read burst operation. Now that means the master wants to perform a read operation. This is my master and this is my slave, and the master wants to read the data from the slave like this. If it wants to, let's say if it want to read the data from the slave. Now what is master going to do is it is going to first of all send the address which is associated with that particular read transaction. So using which bus it is going to use, it is going to send the address is it is going to use this bus which is known as AR address bus, AR bus. So it is going to use this read address bus. Let me show you that particular channel. That is nothing but read address channel. It is going to use this read address channel, and it is going to send the address using AR address. So the master is going to use a bus which is known as read address bus, and it is going to send the address using AR address. It is going to send the address using AR address bus, and it is going to send the address to the slave, and it is going to tell that from which address it wants to read the data from. So after that particular address appears on the address bus, the data transfer occurs on the read data channel. Okay, so we are going to get the data on AR data bus. After providing the address to the slave is going to provide the master the respective data using AR data bus. Now let's see one example of how it is going to happen. So this is my T0 to T1 clock cycle. Let me change the ink color. 1 minute. So this is my T0 to T1 cycle, and in this T0 to T1 cycle, the master is going to provide the address using AR address bus. Using this AR address bus, the master has provided whatever the data which it wants to read from that particular address it is providing using this AR address signal. Now let's say in this particular example, the address is A. Now we have one more signal which is known as valid signal. Now this valid signal is used to indicate that whatever the address which was sent by our master is a valid address or not. Using this valid signal, the master is going to say the slave that whatever the control signal or whatever the address signal the master has sent is a valid signal. So using this AR valid, if this is equal to 1, then the address or the control information which was sent by the master is a valid information. Or else if this AR valid is equal to 0, if this AR valid signal will be made to 0, that means the address information or the control information which was sent by the master is not a valid information. So we need to make sure that the master need to make sure that this AR valid signal is made to 1, so that the master confirms the slave that it is going to send a valid information, or else if the information which was sent is not a valid information. Now after sending the address and control information and the valid information, AR valid is made to 1. Now the slave need to respond to the master that it has successfully sampled the address and control information. Now how is slave going to respond to that particular information? It is going to respond using the signal which is known as AR ready. So using this signal, the slave is going to say the master that it has successfully sampled the address information, or it has successfully completed the sampling of the information, so that the master will remove the information which has provided, or it can change the information, the address and control information, it can change that. Okay, so until and unless if this AR ready is not made to 1, the master is not allowed to change the address and control information. So this is a handshaking mechanism in the case of address channel we are going to have. In the case of address channel, let me show you one more time. In the case of your address channel, after providing your address information, the master is supposed to pass one signal which is known as AR valid. If this AR valid is equal to 1, then that means the master has successfully sent a valid signal. Now, after the slave, if it wants to respond, or if it wants to acknowledge the master that it is ready for the transaction and it has successfully completed the transaction, it is going to use one more signal which is known as AR ready. This is given by our slave and this is given by our master. Now let's say if you think that slave is not ready for any type of transaction, or let's say if it wants to have some more time, then we should not make this AR ready to 1. If we make this AR ready to 1, then the master is allowed to change the information, address information. So the slave, if it thinks it needs some more time for the transaction to be happening, or some more time for the sampling to be happening, then we are not supposed to make this as 1. If we make this 1, then the information, the address information which was present will be changed. Okay, so and the transaction will be completed because the slave has given 1. Okay, so we need to be careful in this particular case. Next, after completing this address transaction, next the master needs to read the data. Now, who is going to provide the data? The slave is going to provide the data. Okay, so here somewhere here in the T5 to T6 cycle, we are going to get our data which is corresponding to the address A. Okay, here we are going to get the data which is corresponding to this particular burst address A, and you can see it is a burst. So in this particular burst, we are going to send 4 transaction items. 4 data items are being read by our master. That is 4 transaction items are sent by our slave. Now, how the master is going to know what is the last transaction item? Using this R last, we are going to decide what is the last data item which is present in the burst. So in this case, you can observe the R last is made to 1 here. That means this particular transaction item is the last data item which is the slave is going to send the master. So the slave is going to use this R last signal. The slave is going to use this R last signal to indicate that particular data item is the last data item in a burst. Now, and again slave is also going to use this signal which is known as R valid signal. That means whatever the data the slave is sending to the master is a valid data or not. Using this R valid signal, the slave is going to acknowledge the master. So you can see whenever we are sending the data, we are making this R valid to 1. And again here also, whenever we are sending 2 data items, we are making this R valid to 1 continuously. And for the third transaction, and for the fourth transaction also, we are going to make this R valid to 1. And how the master is going to tell the slave whether it is ready for the transaction or not ready for the transaction is using this R ready. You can see here our R ready is equal to 1. That means master is ready for accepting the data items from the slave, and whenever your R ready is equal to 1, that means your transaction has completed by the master and the slave is allowed to change the data. And here also you can see the master is ready for accepting the transaction and it has successfully completed the transaction. So this is how your master and slave are going to perform a read operation, and this is how we are going to read the data from the slave. Now let us take one more example where we are going to have overlapping read burst example. So in this particular example, we are going to provide the address, that is, this is the address, this is the initial address. A is the initial address of a burst. Here in this example, A is the initial address of the first data item, that is this data item, the initial address is A, and from the next data onwards we need to calculate, and how to calculate that we are going to learn later. Okay, and after the master providing the read address, and it is also going to provide a signal which is known as AR valid signal. That is, whatever the address information the master has sent to the slave is a valid information. So the master is acknowledging that whatever the address information it has sent is a valid information, it is acknowledging. And after receiving that particular address, if the slave asserts A ready to 1, then that means the transaction will be completed. Okay, and here also our A ready is equal to 1, that means our transaction is completed. Now after performing this address information, after receiving all the address information, the slave is going to provide the data information which is corresponding to the first address, that is DA0, DA1 and DA2. This A1 and A2 we are going to calculate by ourselves. The slave is going to calculate by itself using the base address which the master has sent, that is nothing but our A. A is the initial address or base address the master is going to send it, and the slave is going to calculate this A1 and A2 addresses. And next, after, the slave is going to send the address which is known as the slave is going to send the data which is corresponding to B0 and B1. So the master has sent an initial address B. So from this initial address, the slave has calculated the address B1. Okay, and here if you can see, R last is made to 1 here. That means for this transaction, for the transaction A, which is corresponding to address A, this is the last data item. And for the second transaction, which is corresponding to address B, this is the last transaction. Using this R last, the slave is going to assert the master. Now in every case, whenever the slave is going to send the data to the master, it is asserting R valid signal. It is asserting R valid signal, so that the master will come to know that whatever the data the slave has sent is a valid data. And the master is also asserting this ready signal to indicate its readiness and to indicate the completion of the transaction. Now let us try to understand this read transaction with one small example. This is my master and this is my slave. Now first of all, the master wants to perform a read operation. That means the data will travel from slave to master. This is my read operation. Now to perform a read operation, what the master is going to do is it is going to use the channel which is known as read address channel. For performing the read operation, first of all, the master is going to use the channel which is known as read address channel. Now in the read address channel, we have a signal which is known as RAR address. Using this signal, our master is going to send the address to the slave. Using this signal which is present in the read address channel, our master is going to provide the address information to the slave, AR address channel. Now after providing the address information to the slave is going to also check for one more information, that is valid signal. So the master is going to provide another signal which is known as AR valid. That means whatever the address information the master has sent previously is a valid information or not. So along with this address only, the master is going to send this AR valid, so that the slave will come to know that okay, the address information which it has received is a valid information or not. Now after receiving these two informations, the slave is going to provide one more information, that is AR ready. That means the slave is ready for the transaction, and after master sampling this AR ready signal, it will come to know that the slave has successfully sampled all the address information and control information, and it is either going to end the transaction there or it is going to change the address information only after receiving this AR ready signal. If the master is not receiving this AR ready signal, if the AR ready signal is equal to 0, then that means the slave has not completed the previous transaction, and the master will wait for the slave to complete that particular transaction. Then only if this AR ready is made to 1, then only the master is going to change this address information, and whatever the control information it is going to change that. Okay, until and unless it is going to have this AR ready information, it is not going to change. Now after that, what is going to happen is, this is my master and slave. So after receiving the address confirmation, that is address information as sampled successfully by the slave using the AR valid signal, AR ready signal, the master is going to receive the data information using R data signal. So this R data signal is nothing but it is a signal which is associated with read data channel. This is a signal which is associated with read data channel. Using this channel signal, we are going to receive the data from the slave. Now, whatever the data which we are receiving from the slave is also going to send one more signal which is known as R valid signal. This signal is going to tell the master that whatever the information the slave has sent to the master is a valid information. Using this R valid, our master is going to know that okay, the data information which it has received is a valid information or not. Now, after receiving this information, the master, if it has successfully completed sampling all the information which the slave has sent, then the master is going to send one more signal which is known as R ready. So if this R ready is equal to 1, then that means the master has successfully sampled all the information. Then the slave is allowed to change the data information which is present on the bus and the valid information which is present on the bus. If the master has not successfully sampled or it needs some more time for processing the information, then the master is going to provide this R ready is equal to 0, so that the slave will wait for the master to complete its transaction. Now, if it is a burst, that means if it is a burst like this, it is going to send 4 data items. Now, for the master to know what is the last data item which is present in the burst, the slave is going to use one more signal which is known as R last signal. Now, using this R last signal, it is going to tell this is the last data item which is present in that particular burst. So whenever the slave is going to send this particular last data item, it is going to make this R last signal to 1, so that the master will come to know that this is the last data item which is present. Using this R last signal, the slave is going to tell the master that it is the last transaction in the data. This is how your master and slave are going to perform. Now, if I want to perform a write operation. Now, how to perform a write operation, let us try to understand with this example. Let's say this is my master and this is my slave. Now, let's say if my master wants to send any data, because it is a write operation, right? The data direction will be from master to slave. Now, if my master wants to send any data to the slave, first of all, the master is going to provide the address information to the slave. Now, what channel it is going to use? It is going to use a channel which is known as AW address. It is going to use a signal which is known as AW address, which belongs to the channel write address channel. It belongs to the channel write address channel. So using this signal which is present in this channel, the master is going to provide the address information to the slave using this AW address signal. Now, after master providing this AW address signal, the master is also supposed to send one more signal parallel to it, that is nothing but AW valid. Now, what does this mean? AW valid signal is a signal which the master uses to indicate the correctness of this address information. So if this AW valid is equal to 1, then that means whatever the address information the master has sent to the slave is a valid information. If this is equal to 0, then that means the master has sent an invalid address and the slave is not going to sample that. Okay, so the slave is not going to sample the address information. So the master is going to provide this AW valid signal so such that our address information is a valid information. Now, after receiving these two informations, the slave is going to provide one more information, that is nothing but AW ready. What does this AW ready signal means? This AW ready signal is a signal which is going to indicate the master that the slave has completed successfully transaction. So the slave successfully completed sampling all the address informations. Okay, if this AW ready is equal to 0, then that means slave has not sampled the address information and it needs some time, so that the master is not going to change the address information or any other control signal information which is present on the bus. So this is a very important signal to the master to proceed or to end the transaction. Now, after master sending all this address information and getting the acknowledgement regarding this address information, it is going to use one more channel for sending the data. That channel is nothing but write data channel. Now let us try to understand how your write data channel is going to look like. So this is my master and this is my slave. Now, so using my write data channel, the signal which is present in this write data channel is W data. So using this signal, the master is going to provide the data to the slave. So using this W data signal, the master is going to provide the data information to the slave. After and in parallel, so along with this W data signal, the master is supposed to send one more signal which is known as W valid signal. That means whatever the data information the master has provided to the slave is a valid data. So using this W valid signal, the master is going to say the slave that it has sent a valid information. Now, after receiving this valid and W data, the slave is supposed to acknowledge our master that it has successfully sampled our data information using the signal which is known as W ready. So if this signal is equal to 1, that means that our slave has successfully completed the transaction and it has successfully sampled the data information. Or let's say if our slave needs some more time for sampling the data, then it can make this W ready to 0 so that such that your master is not going to change any data information. Okay, so this is how your master and slave are going to communicate with each other in a write operation, in a write transfer. And let's say if it is a burst operation where we are going to send two data items and this is the last data item, then the master is going to assert a signal which is known as W last is equal to 1 when it is sending this particular data item. So the slave will come to know that okay, this is the last data item. Okay, so this is how your master and slave are going to communicate with each other. So you can see the waveform timing diagram. Let me show you. So in the T0 to T1 cycle, the master is providing a address using write address channel, and it is also going to provide a valid information. That means the address which was sent is a valid address, and we are getting AW ready from the slave. That means the slave has successfully sampled the data, and after completing this address phase or the address information, we are going to another phase that is known as write data phase. So here our master is providing the data to the slave using this W data bus, and here whatever the address which was used by our master is the base address in this particular burst. So for first data item, that is the base address, and from next address onwards, the slave is going to calculate what are the subsequent addresses using this particular base address. Okay, and using this W last signal, the master is going to tell the slave that this is the last data item present in this burst, and using this W valid signal, the master is going to tell whatever the data information which the master is sending is a valid data. And for getting the acknowledgement, so using this W ready, we are going to get the acknowledgement that the slave has completed successfully sampling all these particular data items. And if we want to get any response from the slave, using this B response, we are going to get the response from the slave. So here we can see, so using this response channel, write response channel, the slave is going to send the response to our master. Here the slave is going to send the response which is okay, and the response which was sent by the slave is a valid response or not. Using this B valid signal, the slave is going to tell the master that it is a valid response, and the master, if it has successfully sampled the data, then it is going to use this B ready signal. So here successful sampling is going to complete. Okay, so we will discuss more about this valid and ready handshaking in more detail, because if you can see here, B ready was made to 1 from here only. okay, but where is the transaction is going to complete? At this particular point the transaction is going to be completed. Okay, so exactly what is happening and how the transaction is going to complete using this be ready and be valid, how to decide that and all we are going to discuss later. Okay, so it doesn't mean that if you are going to have this ready signal before this valid signal, then here only the transaction is completed. No, so at this point the transaction is going to be completed. Okay, that I will explain later. Okay, so this is in our particular session our main focus is how your master and slave are going to communicate with each other using this particular signals, and in our next session we are going to focus how this valid and ready signals are contributing to decide when the transaction is going to complete. That is what we are going to learn in our next session. Okay, yes, so that's about this particular session. If you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.